One, two, three. Okay. I think you can hear me now very well. Hello, everyone. Actually, we are streaming on 3 platforms at the moment, and I am hearing my own voice with 5 seconds of delay. Let me see what I can do, actually. We are streaming on 3 platforms at the moment, and I am. Okay, I just muted myself. I mean, I muted my speaker, which essentially means that I cannot hear you, but you can hear me, right? So you can you give me thumbs up? Cool, cool, cool. Thank you. And yeah, I have a very strange setup here. My camera is on the left and I see you on the right. So let me at least change this here. Cool. And the plan today, I will shortly get into the plan as to what the plan is going to be. I think you also see my whole screen, but just in case, I will stop sharing and restart it to make sure I'm sharing the proper thing. So let's share the whole screen again. Okay, I'll share my desktop. Cool. And also, this thing should be closed. Okay, I think we are ready to go. We had around 30 people registered for this event today, and we have 6, but I think we are good to start. Okay, let me actually bring up the presentation to give a bit of structure to our work, and then we'll start. For those who just joined, welcome again. My name is 𝗙𝗲𝗍𝗍𝗃, and today we will have a new flavor, of introduction to C++ with a focus of object orientism. However, our main audience is those who have not touched C++ programming so far, because based on my previous little experience, it is good to start from very scratch. Although people who work with OpenFOAM and people who do want to learn a bit of OpenFOAM development, they already know quite a bit of C++. But actually, there are let's say at the advanced level, I don't say I'm an advanced user, but at the advanced level, there are things that you need to learn from the very scratch, or otherwise you will get confused later on. So it's very it is I think it's a good idea to start from the very basic fundamentals. So today we will start with an introduction to C++, and then in the upcoming week we will actually have another session on the proper OpenFOAM development, for which you have already received an invite. A little bit about myself. My name is Ali, and I'm currently the CTO of TensorFields, which is a OpenFOAM training initiative. At the same time, I'm a researcher at UCD. I'm pretty much actually done with UCD. And well, I have a bit of experience in OpenFOAM, both using, development, and teaching. My focus in terms of the research is wire forming. And well, wire forming is basically, we are not talking about the electrical wires. It is an upstream industry which serves a lot of other industries, for example, oil and gas and automotive. Then, so that was me. In terms of today, what we are going to do today, we will have a 50-minute session now, 5 or 6 minutes of which has already passed. And then after that, we will have around 30-minute mini project, which I'm sure most of you will finish it in maybe less than 10 minutes. And then after the mini project, we will have a very, very brief feedback on what happened today. And hopefully I will see all of you and more than 7 people next week for the OpenFOAM development session. So today we are, as I said, we are going to focus on the very basic ideas of object-oriented programming, as well as writing a very simple library just to understand. Actually, to some extent, one of the goals of this training is also to learn how the file structures work in OpenFOAM, how the files are structured and where they are saved. Then next week, we will get into how to write a PDE solver in OpenFOAM and how to manipulate meshes. So we will do both mesh and field manipulation and also PDE solving in a very fundamental level next week. So all of you are familiar with what OpenFOAM is. OpenFOAM is a tool for solving PDEs. Actually, this was a video from 𝗢𝗲𝗄𝗏, which is a very famous, let's say, influencer on YouTube. Since it is a PDF, unfortunately, I don't have the link here, and I'm sure if I want to find it on YouTube, we will waste at least 5 minutes. I will find it and I show you later on as to what this video is trying to show. So basically, PDE is one of the best ways that human has discovered for describing nature. This is one of the most promising ways that we have discovered so far. But after a while, if mathematics advance enough, we might come up with new descriptions of the nature which are more capable of PDEs. But as far as I know, in computational mechanics, PDEs actually are the queens of modeling. So when you want to model a problem mathematically, you will end up with a PDE basically. A small example is here. For example, yeah, like I said, I work on deformation. Let's say I have a circular object and I want to obtain what will be the deformed shape if I apply these forces. So I start with writing the momentum equation for this object, for this solid object. Then I discretize the domain into a few cells, and then I integrate this equation over every single cell. And when I do this for all cells, I will end up with a linear system of equations, which I can solve iteratively, and I will end up with a deformed shape. So this is basically what we do with every single PDE for any physics. I have a bit of lag on my laptop. Let me see. Did I miss? Yeah, I have missed a few. Yeah, just one slide. Okay. OpenFOAM. We are talking about what OpenFOAM is. So it is a PDE solver. It has a free price tag. It is open source. It is very strong. Is it industry standard? I think most of you, some of you at least, come from the industries which work with OpenFOAM. So you already know that it is industry standard, and many industries work with this. It does have some downsides. Actually, when it comes to developing a proper software, as Bjarne Stroustrup, the creator of C++, says, you write a code, and if the code is too large, you will keep debugging the code for the rest of your life. And that's the case for every single large code base like OpenFOAM. So your code is useless if you do not maintain it. And maintaining a code is a full-time job of a group of expert developers. So those developers need to earn some money for doing their job, right? But since the code is free, it is tough to find a way to actually give them some money. So the revenue stream has been a very quite a bit of a problem for all open source projects. Well, especially recently with the hype of AI, people have come up with new ways to earn money, and actually open source has becoming more and more popular. I would say it has become the standard nowadays. So thankfully, this problem is to some extent solved. Another problem was and still is the documentation of OpenFOAM specifically. We are not talking about every single open source code. This has been also addressed during the years. There are a few books which are trying to addressing the lack of documentation. There is, I think, still a lot of room for having a better documentation of OpenFOAM. Next thing is, so we will actually finishing this parts, and we will start hands-on experience in a few slides. So yeah, we will work on Linux. not Windows, but it doesn't matter. If you work on Windows, you already are aware of the Windows subsystem for Linux, and you can use that. And that's it. So let's start with our basic, simple C++ course. I will open a terminal as I have done here, and I will, well, I will create a directory here, wherever in my laptop, wherever in my, basically, yeah, in my computer. I will create a directory, call it C++ from, okay, I might call it 15 Jan. And I will enter that. And so we want to start writing a very basic C++ code. What we do is I open a file, call it first code dot capital C. I need to move this zoom control so that I can see my terminal properly. Okay. Any C++ code starts with a function called main. So let's have a look at the main function, a very quick view. So basically, in our daily lives, we always deal with functions. Let's say you are going to make a lemonade. So what you do is you get some lemons, and let's say we are the whole process of making them lemonade is called a juicer, and the whole process of making lemonade is called a function. So this process, whether it is a juicer machine or whether it is you juicing the lemons manually, this whole process of making the juice has an input called lemons. And then what this whole process means in details, it means you peel the lemons, you cut the lemons, you add sugar, etc., and you return a lemonade. So I have written here the process of making the lemonade in the C++ syntax. In the C++ syntax, a series of actions, which is a function, is written like this. The first keyword is the output or the return, as it is called in C++. We call it the return type. So we return a lemonade. The function name is the juicer, and the inputs are here. And then whatever comes after inside the curly braces are the function body. So every single C++ code needs to have a main function, which is written like this. The main function always has the return type of integer. The name of the function is always main. It can or can't get inputs, and the function body, well, includes whatever we are going to do with our C++ code, whether it is printing something on the screen or whether it is solving 3 PDEs simultaneously. Everything comes inside the main function. Just a few words about what int means. Well, you know that int is basically what a function, a real C++ function returns is a number of bytes. And bytes are a measure for quantifying computer memory. So int, or there are different names for different amounts of bytes. On some systems, for example, 2 bytes mean 1 int. It is called int by default. So it depends on the operating system and the compiler. Or on some systems, each bytes on the memory are called a double, and so on and so forth. So it also depends on the architecture of the machine, which we don't get into that, just for you to know what int and double and all of these standard types mean. So let's write that very simple program. Our very simple program is gonna print something on the screen. So actually, before printing anything on the screen, I will write it and close it. So if I show what I just wrote, this was the program, int main, and that's it. So the next thing is so it is nothing but a piece of text. For the computer to understand what we mean by this, we need to actually compile the program, because C++ is a compiled program. And so I think we have one chat. Could you please record the session? Oh, of course. I think it's automatically being recorded by YouTube because I'm streaming on YouTube as well. But give me 1 second. I need to find this record button. Well, guys, as I told you, I have come across a very strange problem, that is, I can hear my voice when I turn on the speaker. I can hear my voice, and it's quite frustrating. Unless I can, give me 1 second, if I can solve it and actually, I'm not sure if I can. I think this voice is coming from some of the streams, whether it is YouTube. I think possibly it is YouTube. Yeah, okay. I think now it is resolved. Let me see. Well, guys, as I told you, I have come across a very strange problem, that is, I can hear my voice. I cannot hear my voice anymore. Thank you. Okay. That's good. I think if you come across any problem in the in any platform, on YouTube, on LinkedIn, or on Zoom, and you see something is going wrong, please just open your microphone and talk to me, because I can't just check the chats for the sake of the speed and pace. So I think we are good now. So, like I said, C++ is a compiled program. Your computer doesn't understand what these 3 lines mean unless you compile it. And compiling is nothing but talking to a translator. You talk to the translator and tell him what to do. And then the translator knows both your language and the computer's language, and it translates things into the computer's language. So basically, this in the C++ syntax, these 3 lines do nothing. But let's just compile it for the sake of practice. So it depends on what compiler you're using. I use G++, which is available on most systems. G++, the way we compile our program, which is called first code, it is the name that we give into our code. G++ first code, output some name. I give the same name without the .c. That's it. It is compiled, and I can execute it here, and that's it. So it does nothing, but it gets executed without error. So let's print something on the screen. Yeah, I need to just resize my screen so that I can bypass these zoom controls on the top of my screen. So to print something on the screen, we have a very simple function called cout. Cout, something on the screen. For example, hello. And go to the new line. This is the new line character. And semicolon. Semicolon is the end of an expression in C++. However, there is a concept in C++ called declaration. What does that mean? The compiler does not understand what cout and this less than equal mean unless you tell it. And the way we tell the compiler where these things are defined, where these things are declared, is by using the so-called include directives. Include the special library that tells us where these things are declared is called IO stream. So again, what happened is that we have introduced a new name, a new just cout, the code has no idea what cout is unless you tell it. Also, it doesn't have any clue what these symbols mean unless you tell it. So we tell it what these things mean by including the relevant library. This line is called a header. Actually, so it has many different names. We are actually using an include directive. These are just C++ terminologies. It is an include directive which includes a library, which is also called a header. So we are including a file called iostream. And the reason this is this strange symbols like less than and greater than symbols here is because this library is part of the so-called standard library. So the standard libraries can be included like this. So I recompile the code using my 𝗔𝗲𝗃, etc. So now we get to the next. Actually, if you look at the error, it says, I don't know what cout means. Cout was not declared. It is the error that compiler tells me. That leads us to our next discussion. The discussion is namespace. So actually, my native language is Farsi. And there's a word in Farsi called shir, which can mean a lion. Yeah, shir can mean a lion, but also it can mean milk. So how do you understand what does shir mean? So you look at the context. If the context of so I'm sure that in any language, there are words that can have different meanings depending on the context. If the context is food, you know that the person who says shir, he means milk. But if the context is speaking about animals, then someone who says shir means the lion. So the context of the code is specified by the syntax namespace. So namespace actually says what the context is. In our code, the context is using namespace. The context is standard, or std for short. So this function, as well as this symbol, is defined to mean printing something on the screen only in the standard context. So we say we are talking in the standard context, and here we go. These name and symbol get some meaning. And now if I recompile my program and execute it, you see that hello gets printed. So this was the concept of namespaces. We'll go ahead with objects. Let me see how much time we have left. Okay. So I open my code again. Yeah, like I said, for those who joined a bit late, we will finish at 2:20, around 2:20, maybe 2:25. And then we might have a 5 minutes break, and then I will give you a short project at the end of this, after I introduce you to the libraries and objects, and you have time around 30 minutes to write a code that does something interesting, and then we will have a closing and feedback at the end for 10 minutes. So let's get into the concept of the library, objects and libraries. So assume a university. The university has a number of students. The students are there, and every single student is an object. For example, Januar, Brian, Jawad, etc. All these students are common in the fact that they are students. So student on itself is not an object, it is a concept. So student by its own doesn't occupy any physical space. But every single student actually has a realization. You can go see them, you can go talk to them, they exist. However, the student concept, it is just a concept. So this is the concept of the class. However, all of these students, apart from all of them being students, all of them have, for example, student number. And also all of them are privileged with some common actions. For example, all of them are allowed to go to the library and borrow books. So these data which is common between them, for example, the student number, all of them have names, all of them have last names. All of these are called data members of this class. And the actions that all of them are allowed to do is called member functions. So all the objects of the class students have data members and member functions. Let's get into another example. For example, colored circles. So the fact that every single circle here is an object because we are seeing these objects. These are distinct objects. But the concept of a circle is just a concept. It does not have a realization. It does not exist. So these things are the objects of the type circle, and this class has a number of data members like diameter. Every single circle has a diameter. Every single circle has a color. And also, you can calculate area for every single circle. So area is a member function. Same goes for the CFD. So, for example, the mesh. You can have mesh around the Formula 1 car, around turbine blades, around a ship's propeller. The fact that all of these are meshes make them to be an object of type FV mesh, which in OpenFOAM is the short for finite volume mesh. So all of these are FV meshes, and all of them has many common attributes. For all of these meshes, you can access every single point. You can see how many faces you have. You can actually change the mesh. All of these, which actually we will get into some of these next week in our OpenFOAM developer training, no fluff. Same time, same day next week. And all of them has a number of common functions. For example, we can move the mesh. We will scale the mesh next week for an example mesh. So this was the concept of the objects, the classes, the member data, and the member function. So the next step that we are gonna do is actually writing a class for writing a simple circle class. The notation for classes is like this: circle. So this is the simplest class you can have in OpenFOAM. You can have in C++. You say class name, curly braces, and semicolon. This is, I think, one of the few places in C++ that you have a semicolon after curly brace. Like a function, actually not much like a function. Actually, inside the curly brace, you have the class, you have the body of the class. However, not like a function, the text, the code inside the curly braces does not get executed. We will get into that. I'm gonna write a class of circles that enables me to calculate the area of the circles. So actually what I'm gonna do is, let me save this code into circle dot. Yeah, I want to calculate the area. So let's save it into calc circle area.c. Now I'm into this new file. Calc circle area.c is what I'm gonna do. In terms of the object-oriented programming, what will finally happen in the main function is that we are gonna create a circle, let's call it C1, and we want to call a function of this circle called area. Actually, this is the gist of object-oriented programming. You can see the code gets very simple if the coding style is object-oriented. or if the mindset behind the code is object oriented, because you actually, this is pretty much the same way that we think of things. I create a circle and I calculate the area in the second line. So this is just the object oriented design that allows us to do so. Now, like we said before, we have introduced new names. I have introduced circle. What does circle mean? We should tell the compiler. And what does this function area mean? We also need to tell to the compiler what it means. Don't forget that in order to have access to the member data and the member functions of an object, we use this symbol dot. So C1 dot area means call the area function for this object. Okay, now we start with defining a circle. Here I have circle. Well, basically for the area function, we start with defining the area. Yeah, void area. So void area, like we talked about functions syntax, the first keyword here means the output type. When it is void, it means it does not output anything. So we just want to show the area on the screen. When you want to just show something on the screen, you don't need to output anything. Then we say cout, show the area. What is the area of a circle? The area of a circle is 3.4 pi times the diameter divided by, so let me do a bit of math. Actually, it is the power of diameter to the 2 divided by 4. I introduced a few new symbols. Pow. So star. Actually, C++ by design knows what you mean by star. It knows that you mean it knows that you mean multiplication. However, pow, which means power, is defined in another library, which we are gonna add it to the top. The library is called cmath. So I'll add cmath. And then, so power d2 means raise d to the power of 2 and then divided by 4, and we'll end up with the area. So d underline is the diameter. The reason I added the underline is that, so first of all, we have not defined d yet. D is the diameter. Let's define it. Here, I will call it a double number, not an integer, so that I have the freedom to have any real number as my diameter. I will call it d, and then the area function. Now, the thing that I have used this underline after d is an OpenFOAM convention. When the code gets very large and you are in the middle of 5,000 lines of code of the definition of a class, you need to know which variable is a local variable and which variable is a member data. So this is really helpful that the member data have this special underline after them, so that, for example, if I have some other variable somewhere else in my code, I know that which one is member data, which one is not. So does this code get compiled? Let's get the compilation error and solve it. So I will try to compile my code. As you know, I renamed the code to calc circle area, and output is also calc circle area. So the first error is that the circle area is private. This is the concept of encapsulation in, actually not quite a well description of the concept of encapsulation, but the concept of data encapsulation is very relevant here, in the sense that we do not let anything outside the scope of our class have access to the data encapsulated in our class. in order for, so you see that we create a circle object, that's fine, but as soon as you call the area, you want to call this function, and this function is in the scope of the class. What do we mean by the scope of the class? The scope of the class has two meanings. I will give you the first meaning, and I will get into the second meaning next. The first meaning of the scope of a class means everything that happens to be between these two curly braces is called inside the scope of the class. You cannot have access to these data unless, let me see, I think, yeah, my phone is running out of battery and it is very strange. Give me 1 second. Okay. Now we are good to go. Yeah, the scope of the, in order for something from the outside, like area, like here, what we do, we are outside the scope of the class here because we are not inside the curly braces. But we are trying to access something inside the curly braces area. So we need to declare this as public so that public, which is from the outside, you can have access to this. So what the way we do that is we declare public here. And for the sake of coding style and increasing the readability, we add some indentation here. 4 spaces is normally the indentation in most of the codes, including most of the code bases, including OpenFOAM. So now, when I am allowed to call area. However, there is one more thing. We never gave the diameter a value. We say the area is pi d to the 2 divided by 4, but what d is. So I would rather choose the diameter on the fly. So when I create the circle, I want to give it some diameter. For example, I give it 2 because it makes my life easier. 2 to the power of 2 is 4, and 4 is simplified. The correct result is pi itself. So if it prints pi on the screen, it means that I have calculated the area correctly. So is this function defined anywhere? You see that this is the, first of all, this syntax, C1 parenthesis sum input, looks very similar to a function, right? We have a function, like we have a function name and we have parentheses and we have the input. Actually, yes, it is a function syntax, and this special function which outputs the object itself is called a constructor. So basically what constructor does, and constructor is a very specific function that outputs the object itself. And it is used to, to make it simpler, basically constructor is used to initialize all the data of a class. So I need that circle function. There are 2 things very special regarding the constructors. The first thing is that they do not have a return type like member functions do. For example, area has a return type called void, but circle does not. Constructor does not have a return type. Member functions. What happened? Cool. So, and I want this constructor to get some number, let's say double, get some number like x. And the third thing, which is different in constructors compared to other things, is that they are allowed to initialize the member data of the class in using a very special syntax, like what I am writing now. So colon data members, and then the initialization value inside parentheses x. So what I do, and then the function body, that's it. So you can see that it has a very specific, a very specialized syntax. First of all, the constructor doesn't have a return type. The name is the same as the name of the class. And finally, for initializing the data, you are allowed, and sometimes you have to, use this specialized syntax. We normally use this syntax unless, for some very technical reasons, for example, in some lists in OpenFOAM, it is not related to our discussion now, but when one of your data members is a list, sometimes you cannot use this syntax. You can create an empty list here, and then inside the constructor body, you actually initialize the values of the list. So we normally use this syntax unless we have to use otherwise inside the function body. So our constructor is built now. Basically, this constructor means initialize my data member D with the input value X. So if I look at the main function body, I am doing the same thing. If I go compile it, we will see if we get any error or not. Thankfully, we don't. And I run the code. So hello 3.14. Like I said, pi was the area of the circle, and our code is doing well. So I'll get back into the code. Let me see how much time we have left, actually. Yeah, we are pretty much, based on the previous plan, we have 7 minutes left. Let me set the timer. We have 7 minutes left. For the remaining time, I will give you a bit of, we have 7 minutes left for my presentation, and then I will give you a mini project that you will implement now. In OpenFOAM, there is a difference in the implementation of a class compared to what I have written here. When you introduce a function inside your class, it is called declaration. And a declaration means basically, if I had said, there exists a function called circle which gets a double, it is called declaration. But when I say actually what this function do, how this function initialize the data members, and I add these curly braces, it is called definition. As far as you don't say what this function do, and you just say this function exists, it is called declaration. So it is called declaration, which means this function exists. We have a message here. Sorry, guys, please turn on your mic and talk to me if I'm going wrong somewhere. Sorry, due to an unforeseen issue, I have to leave. That's fine. Okay, sorry. This function exists. So the definition means what this function does. In OpenFOAM, and mostly in all C++ code bases, the definition is done outside the definition and declaration are done separately. So to follow that OpenFOAM, or more generally C++ style, we take the definition out from the class and put it here. Now, this circle outside the curly braces of the circle class is outside the scope of the circle. I told you that when we say the scope of a class, we mean two things. The first thing is, being in the scope of a class either means being in the curly braces of the class or being in the scope by the so-called scope operator. What is the scope operator? Circle, which is the name of the class, colon is the scope. This colon is the scope operator. So this syntax means this circle here is the constructor of the class circle. So now the code understands what circle I am talking about. Also, we do the same for area. So here we just say area exists, and then we take it out. we say this area belongs to the class circle. So in OpenFOAM, you have all the class declarations inside the .h files, also called header files. Whereas you have all the definitions inside the .c files, also called source for short, or source code. And everything that comes inside the main function is called an application. And sometimes it is called, it is called an application. And in OpenFOAM specifically, an application can either be a solver or a utility. A solver like any solver, simple form, or a utility like block mesh, create a mesh. So these three pieces, these three categories of codes are saved in different places in OpenFOAM structure and basically in any C++ code base. Since we don't have time, we just show that on the slides. I don't restructure my code here. Yeah. Okay. Actually, there's one more important thing that I need to cover here. Before I get into the, maybe I explain the file structure a bit here. Yeah, like I said, the applications, if you go to the OpenFOAM installation directory, for example, I have if I have OF12 here and I go to there are a number of directories in the OpenFOAM installation directory. All the applications are in application. So all the utilities and solvers. So I know that OpenFOAM has changed its, especially openfoam.org has changed its design to modular solvers, but I think still modules are in the application directory, but it doesn't change the idea that I'm trying to convey. And all the .h, all the source code files, all the library implementations are coming inside source. So inside source, you have those .h files and the .c files separately. For example, for an FV mesh class, if I go to source finite volume meshes or FV mesh, there are many classes derived from FV mesh, but you can see that all the headers come inside the FV mesh, whereas all the source code comes inside the FV mesh.c. And well, these codes are included in a separate in some other way, sometimes directly during the compile time. These codes are linked. These, for example, FV mesh geometry is linked to FV mesh. This is outside the scope of this training, actually. But sometimes they are, if, for example, they are templated, they are just included at the end of the .h file. Okay, the purpose just for me to show that these three segments of the code, the .h, .c, and the applications, are saved into separate files in separate locations. Actually, specifically the .h and .c, the header files and the source code files of the libraries all are in the source directory, but in separate files. And the applications are in the totally separate directory. So since we are done with the first 50 minutes and we have left 40 minutes to the end of the session, there's one important thing that is left for me to tell you. I will do that in the last 10 minutes. I will give you 20 minutes to implement. That important thing is OpenFOAM style compilation. We have used G++ so far, and we want to see how OpenFOAM compiles programs. It has its own compilation system, which is a wrapper around the system compiler. If you use, for example, Linux and your compiler is G++, then there is there is a compile system of OpenFOAM native compile system called WMake, which is a wrapper around the G++. Or if you use, for example, Mac, it is a wrapper around, what is it, Clang, and so on. So I will show you the quiz that you are meant to implement now in the next 20 minutes. So this is the quiz. Create a class called rectangle, create a rectangle object, and show its perimeter and area on terminal. I will share this on, so I will keep sharing this on my screen for the next 20 minutes. You are meant to implement this, please. And after that, we might have maybe one of you randomly to share their screen and show us their implementation. So good luck with your quiz. Meanwhile, if you have any questions, I'm here. I will just share just this window. Give me 1 second. I stop sharing and restart it again. Cool. I will actually turn off my camera and mic for the next 10 minutes. Then if you have any question, I'll be back in 10 minutes. Okay, guys, I'm back. If anyone is done, just let me know. There's no rush. We still have another 10 minutes, I think. So, no rush. Well, guys, I think our 20 minutes is finished. I'm not sure where you guys could reach by now. Do we have any volunteers to share their screen and show their progress so far? Don't be ashamed if you haven't. You should have written at least 1 or 2 lines of code, so that should be fine. That's more than enough. If that's the case, just let me know. Okay, apparently our Zoom attendees have not written anything. They don't say anything. So let me see if our attendees somewhere else has done. No comments on LinkedIn, and I doubt we have any comments on YouTube either. Well, actually, I'm sure that you guys have done some bit of programming on this quiz, but that's fine. Since we are gonna finish in 15 minutes, I'm gonna. So we have no volunteers, right? If we do, just turn on your mic. I will wait another 30 seconds. Let me reshare my screen. I need to stop. I need to share my whole screen actually. So give me 1 second. Okay. So actually, as you might have implemented, the task is so simple. Where were we? Let me find where I was actually. Okay, I want to show you how implementing this rectangle class can be done if we get time. Let me find. So we had calc circle area.c. I copy this into calc rectangle area and perimeter.c. And I show that calc rectangle. So basically nothing changes. The name of the class becomes rectangle. And I need 2 data members. I need, because I have 2 edges for a rectangle, for a typical rectangle, I have the length and the width. So A and B. So maybe length and width. Then the constructor gets 2 numbers. And interestingly, actually the declaration just needs to know that you get 2 numbers. You do not even need to give it any names. And I need perimeter as well as area. I will have perim. Okay. And then the next thing is I will create a rectangle out of a rectangle. And then I have some A and B. I initialize my length with A, and I initialize my width with B. And the circle area is A, actually length times width. Go to the next line. And the perimeter here I write the perimeter, void perim, actually not circle, here should be rect perim so twice the summation of length and the width is the perimeter. So we have everything, and then I initialize my rectangle, so I don't need hello anymore. I create a rectangle and call it R, a rectangle which is 2 by 3. So its area would be 6, 2 by 3, and its perimeter would be 2 times 5, which is 10. And then I say our area and our perim. So to make it nicer, I would say cout area is this, and also perimeter is perim. And I can compile the code now, G++ calc rectangle out. Okay, I've got a few errors. It says no declaration matches. So first of all, it says what is circle, because we didn't change the name of the class actually. Calc rectangle area and perimeter. The name should be rect. Do I have any circle here? Circ. Yeah, it should be rect. And then, okay, it is compiled without error. Calc rectangle area. So as you see, I could get printed area is 6, quite right, and perimeter is 10. So that's it. So far we have compiled everything using G++ or our compiler, our system compiler. I will get into the OpenFOAM compilation system for maybe 5 minutes, very fast. We talked about the OpenFOAM file structure, and I mentioned that the source code and applications are in different directories. For example, in our case, if we wanted to save our code, for example, circles area calculation code into 3 different files, we would have a circle.c, a circle.h, and an area.c. So the circle.h is the declaration of the class, circle.c is the definition of all the functions, the area in our example, and area.c is the main function. That's it. The last thing is the OpenFOAM compilation system. Actually, I want to show you how OpenFOAM compilation system work. I will create a directory called calc circle area. Well, let's call it, let's create a dummy directory. I move the calc circle area into this newly created directory called A. If I show my current directory, so here's my directory. I created a folder called A. I had to name it A because I already have this name here. Let me move this calc circle area into this newly created directory. Move calc circle area.c into A, and So here I moved my circle area calculation inside calc circle area. I go into that, and I only have two things: calc circle area application and calc circle area source code application and the binary. Okay. How OpenFOAM compilation system works: instead of writing G++, the name of the code, we create a folder called make. Inside make, I need a file called files. And inside that, I need the name of the source code I'm going to compile. In our case, it is calc circle area.c. The code is going to be compiled into an executable whose name is, you remember when we were using G++, we write the name of the source code and the name of the executable. So this second name needs to be specified here using OpenFOAM compile system also. We say the executable exe is going to be saved in foam user application binary. So the code that is generated from compilation, calc circle area, is a binary. It's called a binary code because it is only understandable for the machine, which only understands binaries. The machine only understands 0 and 1. Therefore, I call it, so save this executable to this directory, add cat, and call it calc circle area. That's it. You also need to have a file called options, although we don't need to have any entries in that, but it needs to exist for our simple application, touch, options. So if I open it, it is empty, just an empty file called options. Therefore, this is my directory structure now. I can remove the binary because I'm gonna create a new thing, a new binary file using OpenFOAM compilation system. So I have calc circle area source code, and I have a make including files and options. And options is empty, and files includes the settings that I just showed. Now, using OpenFOAM compilation system, you just need to write wmake. Let me make sure that OpenFOAM is active, OpenFOAM 12, and then wmake. That's it. Our code got compiled. If you look at the output of OpenFOAM compilation system, you see the exact same thing, but with a lot of options. So in my machine, it uses G++ with a lot of compiler options, and it gets the source code file also among all of the options. And finally, it outputs, actually this second stage is called the linker stage. We didn't do that because we didn't need to, but OpenFOAM compilation system is comprehensive and not every single class is as simple as our circle class. So normally for more sophisticated classes, we need a linking process, which I will introduce you to that next week. After the linking process, things are saved in this file, calc circle area. Calc circle area. Where is it? It is inside OpenFOAM user application binary, like we specified. And now the final difference between the conventional compilation versus OpenFOAM compilation is what we do here. We simply write calc. So this last name is the name of the executable, calc circle area. You don't need to write ./calc, etc., because first of all, we don't have that calc circle area with that green color anymore. It is saved something else. It is saved somewhere else inside foam user application binary directory. So we just write calc circle area, and that's it. It prints hello, and it prints 3.14. So this was OpenFOAM compilation system, a very simple introduction to that. And a bit more sophisticated compilation using the linker stage will be introduced next week, hopefully. I will. So actually, yeah, I think we have 1 minute left. So I will share a feedback form with you, and I will be really appreciate you if you can fill that up. It will take you 2 minutes. So I'll share that in the chat right now, and also in the chat in other platforms. Show the chat. So if you don't mind, please click on the link I shared just in the chat and give me some feedback. That would be great. I will share the form on LinkedIn and YouTube also. Officially, we are done. I'll give you another 1 minute before I close the session. Also, feel free to turn on your microphone and give feedback if you like. Okay, guys. I hope you have enjoyed the session and it was useful for you. For all of those who are watching us on LinkedIn, possibly on YouTube, and of course here in Zoom, please do join us next week, same time, same day, for Open Foam Developer Training No Fluff, for which this session was actually a prerequisite, and we introduced you to some knowledge if you didn't know this before. Regarding open foam development and generally C++ ideas. Regarding the content I will, for those who have registered, they will receive an email including the content, of course, for free. So a link to the recording, an attachment, or a link to the PDF that I showed you. And for those on LinkedIn or YouTube, they will, I'll try to repost this event and include those links inside that repost also. We have one comment here. I'm answering the form right now. Thank you so much. Thank you very much. Thank you, Hendrika. Very good, guys. Very nice to meet you. Hopefully, I'll see everyone again. Enjoy the rest of your day or your night. Bye-bye.